over the ACSL contest 2 senior division programming problem today. So first, let's talk about what the problem was asking for. So first, the problem talks about how we're gonna code a simulation of a card game, and here it's called Duo, and then it's kind of similar to Uno in real life, where each card, however, has three characteristics: color, a number, and symbol, and the game starts with two face-up cards and seven cards in the player's hand. And then every turn, the player can choose one of the two face-up cards and match as many cards from their hand as possible and make a pile. And then here we see the rules of the game. For placing a card on another card, we need exactly two of the characteristics to match. So then of the three characteristics more closely in detail, there's the color, and it has four colors. The number, there's four numbers and four symbols. And then here it says a card is represented by a three-character string showing the color, number, and symbol. And then also, decks can have wild cards. That's just one of these three characteristics and would be represented as a string such as color or a number or a shape, and then these cards can be matched if one characteristic matches the other card's same characteristic regardless of what the other two characteristics are. And then here it says our program will play multiple turns of Uno Duo for a single player. And here are the rules of the code for our code. The turn starts with two face-up cards, some cards in hand, and a draw pile. And then it says we need to use the leftmost card in our hand, which is important. So we'll start, if it was an array, for example, we would start at the 0th index every time. In your hand that matches one of the face-up cards and place the match card on the face-up card, creating a pile. If the card matches both face-up cards, choose the first card. So similarly, we have another rule where we want the card to match the leftmost. And then we try to match as many cards as we can in our hand on that one pile. So this is a mistake that I got in my own one. So similarly, we need to pay attention when we're reading the English. Um, for this specific game, you need to choose, once you get one pile, you have to stick to that same pile. So even though a card may match the other pile, you can't put it in that pile. You have to stick to the same pile for that turn. And then each time again, we have to look at our cards starting the most leftmost card. And then if a wild card is at the top of the pile, similarly, place the first card that matches it. And your turn is over when there are no more cards in your hand, or you can't play any of them. And then when your turn is over, we add as many cards as possible from the draw pile so that we have no more than seven cards in our hand, and continue with another turn until you played all the cards in your hand and the draw pile is empty or no cards can be matched. And then here we output the cards in our hand followed by the top card of each pile. So here's an example input. So this is the two piles, and this is the cards in our hand, right? Because there's seven. And then this is the draw pile. And then, so this is an example of a possible game. So first we have, this is pile one, this is pile two. So then we look to see which card will match. And remember, to match, we need two of the three characteristics to match. So this one, they're both red, but the other two characteristics don't match. And this one, they're both three, but the other two don't. So then this card can't go. Similarly, this card can't, because remember, for a wild card, it has to match the one characteristic of the other card. And similarly, this card only has blue and blue. This one has none in common with that. This one also doesn't work. But this one can be placed on this pile over here, right? Because they both have a 3 and they both are blue. So then this card is here. So that's what we see here. This card is put over here. But then we start over at the left again. Remember, we start looking from the left. And here we see this one matches this one. They both are 3 and both are cross an X. So then this one will be placed on this one. And then we start at the beginning again. But this one doesn't match either. This one doesn't match either. But then we have this one, which has the same color and symbol, will be put on top of this one. Again, we start from the left. You see that. Um, None of this one doesn't match. This one doesn't match, but then the blue cross matches, so then that will be put on top. Lastly, we have this triangle can be put on top, and then we can put the wild card, but then none of the cards can be put on top. So then we go back to the draw pile, right? Because that was the condition of the game, and we add as many cards until 7. So now we have 7 cards again. And then we repeat the process until when the process is done, this is what we have, and it says there are 3 unplayable cards left in the hand, and the draw pile is empty. And the top cards in the piles are this one, R4S, and 3 triangle blue. And then on pile 2, so then the output is 3 R4S and B3T. So that's the gist of this problem. Are there any questions about the problem? No? Okay, so then let's talk about coding the problem. Yeah, you can code in C++. It doesn't matter. I think that ACSL accepts it. It accepts Python, Java, and C++. Okay, so how the ACSL contest formatted it is that they had a print result um function, and then you can add as many functions as you want, but you just have to return the result in the print result function. So here, this is how they put the thing. This was given. Okay. And then here we have 3 parameters, which is what the input is. We have the piles, the hand, and the draw pile. So then first, what we want to do is we want to get the 2 piles, and so we can play the game, right, and put them on the file. So how we do that is we just, because they're like they said in the input, they're separated by a space, all we need to do is pile, and then this will just split the string into 2, and then that will be our pile 1 and pile 2. And similarly, we can do a hand array. And this splits it in, and then now we'll have a much more easier data type to work with. Instead of a string of 7 different cards separated by spaces, we can just have an array with each card being their own like index, right? And then to continue, we also need to parse the last input draw pile, and it's very similar to hand where we just do draw pile. And then The problem is we need to consider edge cases in this code. The draw pile might be empty, so if we do that, if we try to call draw pile dot split on an empty string, then an error will come out. So then we need to do this if draw pile. But then else, we just need to return an empty array, and that's what draw pile array will be if we have an empty string for draw pile. Okay. And then next we need to talk about simulating the game after we have parsed the input. So in this game, it technically we don't know how long it can go on, right? Because we don't know exactly how many cards each turn will use or how when the game will end. So we need a while loop. And the easiest while loop is a true loop. And then how we break out of it is when a certain condition is met, we can just use the break function to break out of the loop. So then yeah, we should use a while true loop. So then the first thing to do is at the beginning of each term, we want to make sure our hand has 7 cards, right? That was stated in the problem here. Your program will play multiple turns of Uno Duo for a single player, and the turn begins with 2 face-up cards and 7 cards in hand. So we need to make sure we have 7 cards, or as at least as many as possible with the draw pile being empty. So how we do that is, well, this means is while the hand array's length is less than 7 and the draw pile array has any value or card in it, then we need to add more cards to the hand pile. So then that will be our while loop inside the bigger while loop, and then we just do. So what this is we're appending the first card in the draw pile, the 0th, and then we also need to, besides appending it to hand array, we need to make sure we pop it from draw pile so that the card is like discarded, right? And we don't encounter the card again. So then next we need to know how many cards we have in hand array so that we can check a condition. So this will make more sense in a second. So what this is um we're gonna make a play function that does all the work so that this code is less disorganized and more compartmentalized. And then we're gonna like set pile 1 and pile 2 to be like whatever the results of play are. And then why we need to check the length of hand array is because we want to know if the length of hand array changed after we play. We know that we used up some cards. But then if the length of hand array didn't change, then we know that the cards are impossible to play and the game ends. So this is a very important conditional, and it's the easiest way we can use to make sure that the loop does not go on infinitely. So then here, and then also another conditional for breaking the code is if and what this means is if hand array is empty and draw pile array is empty, then we know like the player won and the game ended. So we can also break there too because we can't do any more moves if we don't have anything left in the player hand and in the draw pile. So then after we break, we can return. And this is just formatting the code, like the code for formatting the string, right? Remember the question it asked for us at the end to return the length of our hand and the two piles. So that's what that will do. So then this code is finished for the print result function. Then you notice that here we have this play function that we didn't define, and that was on purpose, like I said before, because we want to make sure that our code is very easy to debug. And if we add the entire play function within this loop, it'll get a bit like annoying and like hard to work with. So then let's just add another play function below. So we have three different parameters. We have pile one, which is a string, pile two, which is a string, and hand array, which is a list. And then we're returning a tuple. A tuple is going to be the pile 1 and pile 2, which will then be turned into pile 1 and pile 2 over here. So then next, in the play function, what we're going to do is we're going to um, play as many cards as possible as we have in our hand. So how do we do that? So we're going to first set a pile variable, because remember, like the problem specified is that when we choose one pile to add cards to, we need to stick to that pile for the rest of the code and or like the round, and we need to keep only adding to that pile. So then we need a specific pile variable to keep track of which pile we're adding to. And then next we're gonna add a for loop and just add as many cards as we can to each loop. So so we're just trying to find the first card that we can add to like the pile, the first card that matches, right? And then we're gonna set that, and then we're gonna do the for loop. So how we do that is um this basically just takes each value in hand array and we get um the index and the card, like the value of that index, and then we have if we're gonna add another function that we're gonna write in a second, match. So what this does is um if we have a match between, which we'll write in a second, card one and pile one, then we just make pile one the top the first that card, right? So hand array dot pop I, and then again we need to pop it to make sure that we don't reuse the card, and then we set pile to be one, indicating that pile one is the code that we wanted. And notice how we do pile one and then we're gonna do pile two, because like the code said, I mean the problem said, we want to make sure that we achieve what we want with pile one first and then pile two. because it's also left to right. So then next, we also need to write the same thing for pile 2, but this time it's an else statement. And then we have match card 2, card 1, or not card, card, pile 2 equals hand array. And pile equals 2, break. And this makes sense, right? Because it's basically the same code as we had right here, but instead for pile 2. So then next, first, what we need to do is notice how there are 3 options that we can have pile as after this for loop runs. Pile can be 0, pile can be 1, or pile can be 2. And specifically for when pile is 0, we know that if pile is 0, that means none of the cards in hand array matched for the any of the piles, so we know that this round is over. So if pile equals 0, just return pile 1, pile 2. Because we know the round is over because none of the cards matched. However, on the other hand, next we have to play and make sure that each card goes through. So let's write an if statement. True. Again, we want to use a while loop because we're not exactly sure how many cards are matching. And when we're not sure about how many times we want to run code, but we know we need to repeat the code, this is the most appropriate time to use a while loop. So then again, it's kind of hard to write the conditions, so then we'll just use a while true loop, and then when the condition we want is met, then we'll break the loop. So then yeah, we'll use a while true loop. And then in this loop, we first have n equals length and array again. And similarly to over here, the strategy is if n stays the same, we know that none of the cards were placeable, and then we know we need a break and out of the loop. So then we again have an n be length hand array, and then over. So what is this code that I just added? This code is basically, again, we want to go through and from the first value to the last value of the code and check for if each card matches. So then if card matches pile 1, then we set pile 1 to be hand array dot pop I because we need to remove I again. And then we break out of the loop because remember as the problem said, we start over from the left each time. So then if we stayed in the loop would keep going on and it might place a card in the end of the list before a card that might work at the beginning of the list, which will not follow the rules of the game. So we need to break out of the code once we can add a card. And then also now we can do so here again we similarly to the code above, if length of hand array is equal to n, then we break because we know that none of the cards were placed and that round is over. So then next, we basically write the same exact thing for pile 2. So Notice how it was the same exact code, but this time instead of pile 1, it's just pile 2. And that's basically the only difference between those two statements. And then lastly, at the end of this code, all we need to do is return pile 1, pile 2, because we finished running all the code. And notice we don't need to return hand array because hand array is a list and it's not a primitive value, so then it'll automatically be updated and we don't need to update it like ourselves and return it and set up a new like value for hand array. So then next, lastly, what we need to do to finish this code is we need to write a match function, right? Because notice how we use this here, but we never defined this. So then we'll have um and here notice unlike the parts of 4, the functions of 4, we have two parameters, two strings that represent each card, and then we're returning a boolean because the match will just be true or false, right? Because we check match here. So how we check it is let's have an um first the first case, there's like a few different cases for the different card lengths and how they match. So the first case is that they're both wild cards, and the only possibility of matching for wild cards is if they're exactly the same. Because notice how if they're a different color, then they won't be. And the rule for a wild card is that they need to be the same thing for the same type. So then if a wild card is like a triangle, but the other one is the color blue, they automatically don't match because they're not the same thing for the same type. So we need to check for the wild card. It's very easy. It's just if they're equal to each other. So then we have if, so we're just if the length of both of them is 1, then we just return card 1 equals card 2, and this is if they're equal to return true, and if they're not equal to return false. And the next case is if one of them is of length 1 and the other is of length 3. And all we need to know for this is that if one of them is length 1, that means one of them is a wild card and the other one is a normal card. And to check for this, we just need to check if the wild card is in the normal card. Like the character of the wild card is in the normal card, right? Because for wild cards to work, we need them to be of the same value for that specific characteristic. So all we need to do is check if one card contains the other card. So then how we do that is so that's how it works, right? We just return if one of them is in the other, and in just basically means if one of the cards contains the other cards. And the last case is if they're both normal cards. So if they're both normal cards, we just return if two of the characteristics match, and how we do that is And basically, um, what this line is saying is that if we'll make a sum and we'll add 1 for every time a chart in card 2 is in card 1, and then when the sum, after we calculate the sum, we said the cards match if 2 or more of them are the same, so then we'll just return if the sum is greater than or equal to 2. And then that should be it for all the code. And then lastly, we just need to check our code, right? So then do to use the scanner, and then we have what this does basically is we just take input from the stream for piles, hand, and draw pile, and then we'll just call this function, which is all we need to do because it'll call all the other functions for us. And then after we call all the other functions, then we'll print the result. So let's run the code. Maybe. Okay. So now let's test the code. First we add in the piles, and then the hand. Typo. Then let's try again. Yes, we get the results 3RS4S and B3T, which is correct. And we can test some of their other inputs. For example, try this one. Yeah, paste it in all at once. We run it. This shoes. Oh, we need to make sure this is outside the indent. Try again. Yes, and then we get 1Y20G3T, which is correct. And then you can test all the other cases too, and then they should work too. So, specifically in this code, I think this problem was not too difficult. Just make sure like you don't make any typos like I did. Like for example, the hand array, I actually did like an R instead of a D and I forgot to like or I accidentally didn't index correctly. So yeah, that sums up this problem. And then now let's quickly go over the short problems on the test. So let me pull up the short problems. I couldn't find the exact short problems, but then we can just go over some problems that like were similar to the ACSL contests. So then this isn't extremely up to date, but on the ACSL contest of the second one for this year, there was definitely bit string flicking, and I think Boolean algebra is for the next contest. So first we can go over bit string flicking really quickly. So basically we need to, for bit string flicking, we need to make sure we know all the functions. So first order of operations of Boolean is firstly we go and then we have or not, and then we have and then we have XOR, and then we have OR. So make sure you remember this. But then also parentheses will be the most important otherwise. So do parentheses before you take into consideration any of these. So, and then next we have the RCirc function, and what the RCirc function it does is it moves every digit to the right by a certain value, but then, for example, if a digit's at the back, it'll move to the front. So RCirc2 for 1, 1, 0, 0, 0, it'll move every digit 2 digits to the right, but these two zeros will be put in the front. So basically think of RCirc as taking the most right or most however many digits and just putting them at the front. And this turns into 0, 0, 1, 1, 0. And then we have the L shift, and left shift does the opposite. It moves everything to the left, but also it won't move it back to the back. It's just the new values will be 0 by default. So L shift 1, 0, 1, 1, 0, 0 takes the right 4 digits and moves them forward and just gets rid of this digit and adds 0 in the back. So that will be L shift 0, 1, 1, 0, 0. And then XOR, just a review, is if it means exclusive OR. So that means it'll return 1 if there's a 1 and a 0, or a 0 and a 1. Return 0 if it's 1, 1, and 0, 0. So then we have X, this that string, XOR this bit string. So then this is a 0 and a 1, and they're different, so it's 1. The next one's 1. Also 1, 0, 1, 0, 1. But then last we have 0, 0, they're the same. So return 0. So then the answer to this is X is 1, 1, 1, 1, 0. And then for values of X that satisfy this equation, the easiest way to find values that satisfy a certain equation is we set X to be the random values A, B, C, D, E. It doesn't really matter in this situation. So usually I would do this, and then I would like sometimes there's more bit string flicking with X, like for example they'll do like R circ 3 or like L shift 1 like this, and then you'll have to manipulate the function. But another way, for example, in problems like this that don't really manipulate X, you can work backwards. So then we know R circ of this is equal to this. So then we can work backwards and find what this is. And this is left circ 3 of this. So then we take the leftmost 3 digits and move it to the back. So it's 0, 1, 1, 1, 0. And that's the same as, so R circ of 3 of this is equal to this. So then we know that this function is equal to this function, or this string is equal to this string. And then next to find X, we know by order of operations that OR goes second and goes first. So then we can find what possible values this string can have. So this string or this string is equal to this. And for or, if we have a zero, we know that both values had to be zero. So we know for a fact that 0, 0, 1, 0, 1, and x equals 0 because 0 and 0 is the only way to get 0. But then we also have that this and x, or this is equal to 1. And because there's already a 1 here, it can be either a 0 or a 1. And how we represent that is we'll put an asterisk. So this value could be anything because there's already a 1 here, and in 1 or anything is still 1. And then because we have a 0 here and there's a value of 1 here, we know that this value has to be 1 because the only way to get 1 if you already have a 0 with or is another 1. And then for the fourth string, because we have 1 again and it's 1 here, it's another asterisk. Then lastly, it's 0 again because the only way to get 0 with ORs is two zeros OR together. So we have this new function or equation that is much more simplified than the equation we had before. 0, 0, 1, 0, 1, and x equals 0 asterisk 1 asterisk 0. So first we know for sure that the second and fourth bit in x are both asterisks because it doesn't matter what the outcome of this function is. We know that it doesn't matter and it can be either 0 or 1. So then we set those to be asterisks again. Then we have 0 and x, the first value, is equal to 0. And 0 and anything is equal to 0 because and needs two values of 1. So we know that the first value can be anything again. And then the third value is 1 and blank equals 1. And we know that the only way to get 1 with and is another 1. So then we have 1 here. The last value, similarly to the first value, 1 and, or no, not similarly. Then we know that this must be 0 because I have 1 and a value is 0. And the only way to get 0 is as if at least one of the digits is 0. So then we have that this is the answer, that x is 0 asterisk 1 asterisk 0. Are there, or sorry, yeah, wait, the first value can be also be an asterisk because if we have a 0 already, yeah, sorry, I wrote that wrong. And this is the final possibilities for x. So just remember when you do bit string flicking that um it's possible to get, remember specifically order of operations and the different functions of what they do, and then also that when solving you can employ the different strategies that we talked about today, and also that make sure to keep in mind that sometimes there's multiple possibilities and it can be an asterisk. And then another topic that was in second contest was let's go over. Okay, so two um we had Lisp, and Lisp we can just look at. Lisp was again similarly to bitstring functions. Just remember that we have order of operations and then remember what the different functions do. So for example, we can do this problem. sub 2, 4. Just remember to follow the parentheses too. We have -2, 3 to the power of 2 is 9. And whenever we have functions like this, it's the first whatever the second. So it's like the first minus second, third to the power of the second. And then we have multiply. It doesn't really matter what order they're in because multiplication is commutative. And then we have multiply 3 and 5, 15. Exponent 2 to the fourth, 16, sub 4, 1, 3. And then we just add these all together. Notice these cancel out, and it's just 16. So that's how you do Lisps. And then another important part of Lisp was the CAR function, which takes the very first value of a list, and the CDR, which takes everything except for the first value of the list. So just make sure to review those functions when you want to do the problems. And then lastly, an important part of contest 2 was prefix and postfix and infix notation. And basically how to approach these problems is remember like how the order works. And my recommendation is to add many parentheses because then you'll know for sure how this does. So then, for example, to evaluate the prefix expression, usually what I do is I know that for prefix, the whatever to the left is immediately the what function is applied to the two numbers to the right of it, and then I'll just keep repetitively finding the numbers to do until there's nothing left. And that'll make more sense when I show you guys how to do it. So for this one, the first one I see is this. So then I know this is 6. And then I see a divide and a 6 and a 3. So I know that this whole thing is 2. Then I don't see a number after 2. So I'll go to the next part. And then I see -9, 1. So that'll immediately be applied and we'll get 8. And then we have divide 8, 2. So then we know this is 4. And notice there's two numbers next to each other and a function again. So we know it's 2 minus 4, -2. And then here we have 8 times 3, 24. 6 times 2, 12. 24 divided by 12, 2. Minus 4, 1, 3. 1 to the power of 3, 1. Then we have 2 and a 1 and a divide here that kind of got obscured. 2. And then we have a plus, -2 and 2, which is 0. So then that should be the answer. So just make sure that you follow prefix and infix, like the rules of how the left, like the most to the right function, I guess, applies to the most to the left numbers immediately. So make sure you apply the functions on adjacent functions. So are there any questions about prefix notation? Or can I get more to it? No? Okay, then that will be all for class today, and thank you for coming.